All right, cool. So, hello, I'm Damian, presenting over reverse engineering today. Usually I go in person, but today I couldn't, mostly because I have a demo part, or I did like the demo version of my presentation that I wanted to cover, and unfortunately, my personal laptop isn't working right now, so we'll just have to do it online for this time, okay? But I see a lot of y'all in the crowd, which is really nice. It's good to see a lot of faces, a lot of new faces. So more about me. I work at the RSOC at RGV currently. If y'all aren't familiar, RSOC is the Regional Security Operations Center. So we do blue teaming for like state-sponsored organizations, I guess like schools and people like that, clients like that. But I'm also interested in like different aspects of security, not just blue teaming. I think I've done previous research on like blockchain, software development. I'm currently a senior at the university, a student. It's my last year, my last semester there. I do computer science, so a lot of software development, a lot of software engineering. But besides that, I have a passion for cybersecurity. And getting into the topic of today's presentation, if y'all want to follow along, I posted the notes with a link to my notes in the Discord in general. It's my website, damianvillarreal.com. You can find the notes there because I'm going to be referencing them a lot. So hopefully, if y'all want to follow along, y'all can follow along there. But this is just more of a brief introduction into what Ghidra is and what the tool is. So how many of y'all have used Ghidra before? I can't see y'all, but I'm going to ask anyway. Maybe y'all can like tell me. How does it look over there, Jeremy? How does it look?
I saw 2 or 3 hands up.
2 or 3? Okay, cool. So I won't go too fast then. It's a good gauge. Hopefully y'all are familiar with reverse engineering. If you aren't, then reverse engineering is just taking stuff apart, looking at its constituent parts, and trying to determine what does this thing do, right? Without actually having all the clues, the entire blueprint, right? We try to like find like evidence and clues within these like software applications in this example, and try to piece by piece figure out what it does. So that's what Ghidra is. Ghidra is a disassembly tool. It's not a debugging tool. It does a lot of things, but in this example, we won't use it as a debugging tool. Debuggers usually are made for like dynamic analysis, which is like executing the actual software in like your environment. Obviously, we won't do that today because we're dealing with ransomware, and I don't want to deal with that. That'd be bad. So we're going to do static analysis instead, which is, well, it's just like Ghidra, what Ghidra is made for. So without further ado, if you have the notes up, hopefully you do. If you don't, then you can just follow along visually. We'll get into it. So first, we'll start Ghidra on the side. I'm using a Docker container to kind of just have this isolated from my environment. And if you want to read the introduction, you can. I'll just talk about how this is like a report. It's going to be pretty beginner friendly, pretty like a brief introduction to just what Ghidra is. So we'll open up the file. This is the sample. You can find the sample, I think, somewhere in the file, but if it is, then I'll link it later. I found it on Code Bazaar. So I'll open up the sample, and usually we greeted with Ghidra is we'll have a bunch of these like windows. So on the left, briefly, we'll go over these windows. So the left side has your imports. Imports are pretty important. We won't focus on the other ones here on the symbol tree, but mainly these imports are important because they kind of they give you hints as to like what the program will do, right? So we have these DLLs, or dynamic link libraries. So these DLLs are told like they're like APIs. They're like your program, in this case, the ransomware, will like call these function libraries. Instead of having to program everything themselves, these malicious actors, they'll just use what already exists on the Windows operating system. For example, this kernel 32.dll, it has a bunch of functions that we can use to directly like manipulate the Windows operating system. So these are all pretty important. You see them often. This is the core API, like the core Windows API for Windows. We'll see this shell 32.dll. I want to point this out because it has 2 functions, command line to arg and shell execute. So immediately that should like signal like, okay, maybe we'll see some shell execution some PowerShell maybe foreshadowing. And next we'll go to this like main listing. So this listing is just like the assembly. It's deconstructed from the executable sample that we had before. If you want to look at all the parts of our sample, we'll have these are called sections. So each section has its own purpose. We'll mainly just focus on the .text section. The .text section has all the executable code in it. Our data is read-only data. Data is like initialized variables and so on and so forth. So we won't be getting into that right now. Besides imports, we have strings. So strings are really important, especially when you're just trying to get like the low-hanging fruit, which is the purpose of today's demonstration. So if you scroll down, you'll start seeing these like readable English, right? These are strings. So immediately you'll see these arguments, which we'll come back to later. If you remember, Akira itself is like a file, it's an executable. And usually when you execute stuff, you want to give them like parameters so that they know how to execute. So these are parameters that the Akira executable will take in order to, it'll change its behavior, right? So obviously encryption path, you can tell it what to encrypt, the percentage of encryption you want, files to exclude, and so on. So those are the strings. In the notes, we can find PowerShell. So if you Google PowerShell down here, you'll find that there's a command to remove Windows shadow copies, which is pretty interesting. Shadow copies are like snapshots that your Windows machine takes in order for recovery. But this ransomware obviously doesn't want you to recover anything, so it'll remove them. So that's another little interesting tidbit you can find just from the strings themselves. So another thing you can find from the strings is the ransom note itself. So we'll see, like, let's look up the README. Maybe we'll find it there. So we found the readme.txt. That's interesting. So that's like the ransom note that they'll leave on your computer once it's encrypted. On the notes, we have this address. So we can go to this specific address if you just go to navigation, you can paste the address in there. So it's 1400 FB0 D0, I think. Okay, yeah, and we have the ransom note here. So, hi friends, whatever you are, your company's dead or whatever, or wherever the language you took, don't cry about it. It's just a ransom note. At the bottom, you'll see that there's like a Tor link. So a link to their Onion site. I think it's here, yeah. So you can send them money if you want to. I don't recommend it, but you can if you want to. And this is like the main page on the left, you can see. This is like what you will find. You can find recently hacked companies, which, although this ransomware, Akira, and I didn't mention it, but this is a little brief introduction on the top. It started in 2023, or they were initiated again in 2023. It's still kind of relevant to this day, even though it's kind of fallen off because of some things I'll get into later. Not limited to it being reversible. Like there's more EDRs can find signatures for Akira. They're a lot better at stopping it. But still to this day, I think on the 16th, there was a ransomware breach in like Washington or something that was dealing with Akira. So it's still relevant to this day. People are still getting infected with Akira. So you can find them here on their website. You can also find important extensions. So you'll see that we have a lot of .exe, .dll. We won't get into it here, but these DLLs or these extensions, I mean, they're like exclusions. What the ransomware doesn't want is it doesn't want to break the system because then you'll never be able to pay them, right? So ransomware, you'll notice that sometimes they'll have like these exclusions so that it doesn't encrypt too much. It doesn't encrypt like key Windows files, like DLLs, for example. DLLs, we need them to do our evil, right? We need them, our functions to actually commit to what we're doing. So you'll see that these will be like excluded DLLs, EXEs, so on and so forth. .sys, system files. And we also see this extension. So it's .arica. It's not Akira, so it's a little bit of a typo. They mentioned this in the ransom note itself. It'll be like, deleting files with the .arica extension, don't do that. So I don't know if it's a typo. I'll have to ask them. I've seen previous reports also like notice this, but some don't. So it depends on the variant you got. Some will encrypt your files with the .arica extension, and others will just encrypt them with the .akira extension. So it depends to what you got. But here we can instantly find that from the strings, and we haven't even done like any deep analysis yet. And we've already found like all these little tidbits, interesting little tidbits. So where do we even start when it comes to all this, right? It's kind of big. We can start with the entry function. So what the entry function is like the start of the execution of the software or the executable. So I think I already have it labeled here, but if you did it, if you had no clue what the entry function is, you could use a tool like object dump. So object dump is another like disassembly tool. So object dump -f, and then we give it our sample. I'm in the wrong folder. Let's go to the right folder. Let's see. Let's see if our, okay, it's not here. Well, object dump will show you the entry point of the function, but I already have it here, so let's just go to it. Let's go to entry. And did it find it? I think it found it. Let's go back. Let's take off the strings, and yeah, we found it. So on the right, you see this decompile frame or window. Decompile just moves the assembly to C. Like Ghidra does its best effort to convert all this assembly into C language, but it's never like one-to-one. Usually, it's always kind of iffy. But here we have our entry function, which is a good place to start. We have two functions inside of our entry function, which one is called security init cookie, and another one is unnamed. You'll see a lot of these like fun underscore blah, blah, blah. These are like stripped function names. So usually ransomware or malware in general will have lots of like obfuscation behind it. We'll have things like packers and cryptors. They're just different ways to obfuscate the code itself. So people like you and me, reverse engineers, won't be able to figure out or be able to crack these malware. But this sample in particular wasn't packed, and it was like minimally obfuscated. So only function names were stripped from the malware. If we go to security init cookie, we'll see that it's a pretty short function, only 35 lines. And if we look into these function names, which give us a huge hint as to what this function does, we have get file time, we have query process counter, get process ID. It's just a lot of like mundane things. Instantly, we know that this probably isn't the core of the malware. And if you Google this function, security init cookie, it's actually a way to win like Microsoft, the C runtime, the CRT, prevents like buffer overflows in software. So it'll have a cookie in the stack, which is a memory like data, like a memory data structure. We'll have a cookie there, and we'll have another cookie called the global cookie. And these two cookies will compare in the beginning and at the end of execution. And if they're the same, then there was no buffer overflow. But if they're different, then there was, and execution will just stop immediately. So it's just a security feature. So now we know that's not what we're looking for. So we can go back to our entry function, and we'll find this. Let's click on this function. Like, what does this do? So let's click on it, and this function's significantly longer. We'll see things like initialize, startup block, some more initialization. And then we see these two functions, get show window mode and get command line. So this looks like execution to me. In particular, this looks like when you open a program, you get this like window, like how Ghidra opened up for us. Same thing, you get this GUI window, and you get this command line. So it looks like we're getting arguments from the command line. And if you remember, we pointed out earlier that we had some arguments we could pull from our strings. So if we scroll down, I think I mentioned them somewhere here. So we have these arguments that our program will take. So this kind of gives us a big hint as to where our main function is. And I've already labeled it, but previously, if you were to open this example up by yourself, you wouldn't find this main function being called main. It'd be called like a generic name like this. But just for the sake of demonstration, this is called main already. So I determined this by finding out like just the process of elimination, right? We figured out that all this before is just initialization, and this looks like a deinitialization or like cleanup, right? We're cleaning up threads, we're cleaning up memory. So, and we know it has to be between this section and this section, our main function. So our main function, let's double click on that. We know it's this one, and it's taking a little bit because this is like, the main function is where all the logic happens. So we have this first section is variable declarations. So these are all just different types of ways to declare variables. If we scroll down for a while, we get into this. So this looks a little bit interesting. If you ever looked at like Splunk logs or EDR logs, they're usually timestamped. So what Akira does, interestingly, is it also has logs for itself. So this is it formatting the string formatting time. So it formats the local time into a string, and it uses that to like timestamp its logs. So that's one thing we can determine from this main function. If we keep scrolling down, that's a lot of like gibberish that we don't care about. And then we get to get command line. So when this executable executes, it'll get our parameters that we passed it earlier. And if it's this variable, then it'll do this, right? Or if it doesn't find it, then it'll say it failed. But this whole part is just it initializing itself. So depending on what we fed it, it'll spit out some kind of like like it'll react differently, right? It'll do something different. If we keep scrolling down, we'll find more. Oh, we found a parameter. Here it is. So this is it formatting into a different type of string format. But this whole section, we can tell, is just like how it takes arguments, right? And if we keep scrolling down, we'll get more and more like technical stuff that I won't get into. So far, we're just still in the parameter section. And these strings are like huge hints as to what this does, right? As previously mentioned. So we'll keep seeing these strings, keep scrolling down, more strings. And this kind of just goes on for a long time, right? We have, let's see, like 1,300 lines, which we won't get into today since this is like more of an introduction. So we'll find out that the crypto engine is somewhere in here. And if you want to find out how I got to that crypto engine, we can basically we go through like all these different parts of the main function, and we can dissect this main function into like a lot of different parts. On the left, you'll see that I turned the assembly into like C or C programming language. So we'll have this thread allocation. So threads are like the way it's like you can think of them as like workers. So like these little workers will work for the program, and that's what threads are. So these threads will do different tasks. So in the Kira, for example, we'll have threads that parse folders. We'll have threads that look at root folders or like system folders, and then we'll have threads that actually do the encryption. So here, Akira divvies up 30% for folder parsing, 10% for root parsing, and the other 60% for actual encryption. So this is the crypto engine initialization. So if we go to, we can find this, we can navigate to this. If we copy the, let's see, this function, copy that, we can navigate to it here. Let's see. It's function 1400B7 1A0, I think. No, 1400B7 1A. Okay, I may have to take this off. There you go. Okay. So we found this function. This is our crypto engine. Like I mentioned before, we didn't see any crypto libraries imported, right? So ransomware does this, or malware does this, so that like these crypto calls don't get intercepted by the EDR, which is one way that they hide. But Akira's crypto engine has flaws, which I won't get into, but that's how we were able to like crack it and figure out like a solution to de-encrypting, not only de-encrypting, but completely like removing it from your like your endpoint. So I think that concludes the general introduction to Ghidra. So we found out, like, just to recap, we went over like the different parts of Ghidra. So we have the symbol tree, which tells us our imports, exports, which is only the entry function, different functions, which we take functions from our imports, from our DLLs, and we can also define functions separately, like we did here. We have this custom function, this custom crypto engine function that isn't defined in the DLL, right? We found command line arguments, like I mentioned before. This executable, or this ransomware takes different command line arguments. Evidence of logging. So Akira will log itself, kind of like how a regular program will log itself. And then we found out that there's deletion of shadow copies. Like I mentioned before, you can find evidence of PowerShell. So this would be like an indicator of compromise. If you're on the blue team, you would like, hey, if you see this command, then you know that there's some evil going on. And I think that pretty much concludes my quick demo of Ghidra. All my notes are here in the blog post. So if you want to follow along and start your own little Ghidra reverse engineering adventure, then you can follow along with this one. I cited all my sources, so if you want to look into more, you can find them here. But that concludes everything. So if there's any questions, I'll take them now.
Yeah, if anyone has any questions, I had a mic here. Hold on.
Hey Damian, what's the URL to your blog page? It's a little small. We can't see it from here.
I'll put it in the it's in the RGV cyber general chat. I can put it in the Google Meets too. So
That'll work. Thank you.
Yeah, it should be in RGV cyber. I can't type in the chat; it's off for some reason. But yeah,
gotcha.
It should be in the
Thank
chat. Mm-hmm.
Any other questions? Doesn't look like any other. Oh, hold on.
Is there like, so like, you're kind of like checking what the executable does. Is there like a different range? Like, I think this maybe looks like C. Do you see them like in other languages more than others? And as you're like, going through your process to identifying, I guess, do you have to be well versed in all the languages, or what does that process look like?
So like the process of like figuring out what the executable does.
Yeah.
So usually Ghidra will just try its best to convert assembly to C, because C is like the next level from assembly. Assembly is like the low level, and then you get to C. So most of your analysis will come in C, especially when it comes to like reverse engineering, since that's just like as low level as it gets. It's like the balance between low level and human readable. So yeah, if you want to get the most out of reverse engineering, you'll most likely have to be well versed in like C or C++.
Okay, cool.
Awesome. Any other questions? Okay, I think we're good in the room. That was awesome. Thank you.
Thank you.